No matter where you go, you run into ESF students solving the world's problems.
The role of graduate students at ESF is really important. These students are the drivers and engines of any of the projects that we have at the college. It is their output as well as their thought processes that contribute and expand our knowledge in all of our research areas.
They really challenge me to think outside the box and to bring in non-default ways of thinking, which I think is really important for trying to generate science that will be helpful to policymakers and to our basic understanding of how the systems work that we study.
As you grow through your science education and your journey, you find that what you do on paper doesn't always work in the laboratory. So being able to overcome those pitfalls is very important in becoming a scientist, being able to think on your feet and change the experiment.
Professor Collins has been instrumental in sort of forming my expertise and expanding on my skill set. She actually opened up the world of computer programming and coding to me as a tool for scientific analysis that I had never been previously exposed to.
Our project, the Center for Environmental Medicine and Informatics, is really meant to try and bridge the research agenda of basic science and the practice of clinical medicine.
It was two different worlds I didn't think connected, but actually came together really well.
The Chestnut Restoration Program was started about 27 years ago, and it's to try to save the American chestnut tree. So what we're trying to do is make a tree that's resistant to this blight and restore it to the forest.
Of all the greenhouse gases that man has let into the atmosphere, about 15% of that total has come just from producing steel and cement. If we can come up with a way to build that doesn't do that to the environment, and in fact at the same time uses a material that's able to sequester carbon, we've really got a win-win situation.
I am studying sustainable energy. I conduct techno-economic analysis for bioenergy pathways, so I look at the technical aspects of the pathways as well as the financial aspects and seeing if they are financially viable as well as technically viable in the long run.
Graduate students, for me, help sort of broaden my focus, and I think about not just what's going to happen here in the US, but what's going to happen worldwide.
We need those well-trained students to solve these problems of the future.
Waterfowl is everything for me. It's what I do for work, and it's what I want to do for the rest of my life and for my career.
Because of the work of the Center for Native Peoples in the Environment, we have created a really unique learning environment. There are very few places that enable that science to be linked with indigenous environmental philosophy, to be linked with traditional knowledge.
Now I'm going out into the field where I'll be researching my tribe's traditional plant knowledge, and it's like a dream come true for me.
Financial support for these graduate students is incredibly important to be able to do their work and continue their studies in these areas and to make these contributions that are going to have profound global impacts.
If we really want to do some of the interesting things we do on campus, we are going to have to rely on private donors.
We've been able to very quickly build the number of students that we're working with because of philanthropic gifts, which has helped us to deliver those students into the field. Without philanthropic gifts, we wouldn't have the capacity to train as many students as we have to date.
My research provides lots of real-world benefits. That's something I think ESF provides a lot of that you might miss at other schools.
The opportunity to work with students who are so mission-driven, who are so passionate about the environment, makes it a wonderful place for these creative approaches. It is head and heart driven, which makes it a really rewarding place to do this kind of work.